Hi, today we are going to do the Lab 9 task 2, in which we are basically using Microchip Studio AVRC language and Proteus. The task is basically to display the three interrupts on the LCD screen, and for that purpose, we are using the 4-bit or 4 ports of the LCD. Since we have 8 ports, D0 to D7, but we are going to use it for 4-bit, we will be using the 4 ports. Rest of the 4 ports are not used. Okay, we have opened the Microchip Studio. Go to the project, and from here select the C executable project. Here we will be selecting the um, project name. Since it's Lab 9 Task 2, this will be the location where we are selecting. For now, we are selecting the desktop, so it is saved there. Click OK. We are going to select the port, which is 80 mega. As I said, the code is to display the three interrupts on the screen. Okay, I am clearing this part, and then I will be pasting the code. Since it is longer, we are already pasting the code that is done. So first of all, we have, this is the frequency for the clock hertz that we are using. We are also using interrupt and delay index code. These are the defined pins that we used, and then we used three interrupts at PD0, D1 and D2. However, on the Mega, it is input output 21, 20 and 19. So whenever we will press the interrupt, the LCD will show that this interrupt is pressed right now, and for after a few seconds it will reset. Now these are the pins that we defined for the below code. These are the LCD functions that we are using: LCD port and delay, and then we are using 100 microsecond delay later on. These are the delays after which it will reset. First of all, we are clearing the ports so that we can store the data or the number on them based on the interrupt pressed. Then we are using the read and write command. This is the write command for the LCD, and this is for the character that we are going to display after 100 microsecond delay. Then this is the LCD port, or you can say the LCD sequence designing. We used a 4-bit mode instead of the 8-bit. We are only using 4 bits, so for that we are using the 4-bit display. Here, based on the pulse that is provided, the after providing the pulse, there is a few seconds delay for it to process, and then it goes forward. And after 100 microseconds, it resets again. This is the 4-bit display, 2 lines and 5 cross 8. So based on the 4-bit display, we have 2 lines, and on the 2 lines, how we are displaying it, it is for that. 0 1 is to clear it, and this is to auto increment or to auto increase the number to the next, so it can reset later on. This is the clear function that we used above, so we are describing it now. Then the LCD go to function, that if at row 0 what to display, and if not then what to display otherwise, the if and else function. These are the interrupt flag, that if whatever interrupt is selected, display that interrupt or configure that interrupt. After that, in the start, the LCD will show system ready waiting for the interrupt. Whenever you will press the interrupt, it will show on the screen that this interrupt is pressed. However, if the flag is clear, no interrupt is present, it won't show anything. Now, if flag 1 is present, or if int 0 is triggered, it will show that else interrupt found, this interrupt is found. Then after um, if int 1 is else if int 1 is pressed, it will show that interrupt found, this interrupt is found. Same goes for the interrupt 2. After a few seconds, the flag is reset, and 1.5 microsecond the flag will reset, and it will display system ready waiting for the next interrupt. And these are the vector, or you can say the matrix, for the flags to appear. Now let's build the code. build solution. Okay, now it is built. So let's debug it. We'll be using a stimulator and restart the debug. Now it is the debug. Okay, if we see in the main code, we can see the ports that we are using are off. Yes, we are using the A port. So when we are going to check here for the input output, we are going to use, or we are going to check the input output at port A. Not sure why it is not displaying anything. Okay, let's re-debug it. And the input output status. Okay, we have selected step into. Let's again check the input output ports. Mm, let's reopen the code again. Okay, debugging the code now. Selecting the simulator and restart the debug. Okay, now go to the debug window and input output status. Here it is showing all of it again. Since we are using port A, so we will be using port A, and then we go to and step into. Okay. For For step into further, we are going to use F11 command. Let's make it float and then we will be able to view it. So here you can see the clocks, all of the inputs at A are open, and this shows the delay. Now opening the Proteus for the hardware. Create a new project. Where do we want to save it? As the desktop. Select folder, and here we are using Mega Lab 92. So click OK. Finish. Now the ports that we selected in the code, based on that we will be placing the components here. We are using LCD, and okay, this is the LCD that we are going to use. Pins that we are going to place. As we mentioned in the code that we are only going to use 4 pins or ports, so we only place them at the last 4 instead of the first 4 because these are defined in the code. Okay, 5 volt. This is set on ground. This will be set on ground as well. This one will be on, was on IO22, IO24. This is ground. And based on this pin is grounded because it's pin 23. Then moving on, IO26. Okay, as it is a requirement to write the name as well, so we will be putting it on here. Okay, here we go. Next, what we are going to do is connect the interrupts. The interrupts are based on button. So pasting the three buttons here, button 1, and we are going to connect on one side, then on the other side. Connect the pins. One part is the ground, and this other part is IO21. Okay, because we have three interrupts, we're going to need the button for three times. Based on the pins that we are using, this is IO20 and either is IO19. Now, we will be selecting the ground and the V source. So first of all, ground, and the terminal. Okay, let's name the terminal as ground, and then we are going to use the V source. For that, we are selecting mm, okay. So okay, let's just connect the we need it here, so let's connect it here. Okay, now we need to upload the source code from edit properties. Go here. The second file we made the files on the desktop. The second file that we created was this one. And went to the debug, select the hex file and click OK. Upload it. Okay. Now the system says that it is ready for the interrupt. Now first, this is the first interrupt. Press it. Interrupt from int0 triggered. So now after a few seconds it reset. Again, interrupt 1 triggered. After a few seconds it will reset. Then interrupt 2 found. After a few seconds it will reset. This is all for now.